Good day, I'm Marvin Enriquez, your subject teacher for Probability and Statistics. With this video lesson, we're going to discuss the topic Test Statistic Value and Test of Hypothesis on the Population Proportion. Our lesson objectives. At the end of this lesson, you are expected to compute or the t-statistic value population proportion. Draws conclusion about the population proportion based on the test statistic value and the rejection region. Solves problems involving testing hypothesis on the population proportion. So let's start now with our discussion proper. So let's begin with the definition of terms as a part of our review from our previous discussion. So when we say test statistic is a standardized value that is calculated from the sample data during hypothesis test. So the procedure that calculates the test statistic compares your data to what is expected under the null hypothesis. So we're going to compare the computed value to the expected value, no, under our null hypothesis. Now, the question is that what is a standardized value? So when we say standardized value or values, these are uh, the same thing as your C-scores. Uh, a standardized value is what you get when you take a data point and scale it by population data. So it tells us how far from the mean we are in terms of standard deviations, or how scattered our data or datas are. No. Now, let's move forward with your population proportion. So it's a fraction of the population that has certain characteristics or characteristic. For example, you had 1,000 people in the population and 232 from these 1,000 have blue eyes. So the fraction of people who have blue eyes is 237 out of 1,000. So for us to get the value of the population proportion, we just simply divide your 237 by 1,000. So whatever the result, that will be your population proportion. So the letter P is used for the population proportion. So you would write this back like your P hat now is equal to your 237 over 1,000. For the formula, so both the critical value approach and the p-value approach can be applied to testing hypothesis. So about a population proportion P. So we just simply compare now your critical value here and your p-value here. So the null hypothesis will have the form of A or HO now will be your P is equal to your P sub O. For some specific number, your PO sub O, is equal or in between 0 and 1. So the value of your PO will fall between 0 and 1. Why? Because your Q sub O plus P sub O is equal to 1. So there is no room that PO is equal to 1 or equal to 0. So the value of your P sub O will fall in between your 0 and 1. So the alternative hypothesis will one of the three inequalities. Your P is less than your PO, your P is greater than your PO, and your P is not equal to your PO. If we just simply use this symbol if there is no keyword or words being mentioned in the problem, like greater than, less than, no? For the same number, PO that appears in the null hypothesis. So in the formula, P sub O is the numerical value of your P that appears in the two hypotheses. That's why a while ago I said that your QO plus your PO is equal to 1. That's why there is no room for us to conclude that your PO is equal to 0 and equal to 1. It uh, should fall no in between your 0 and 1. Is the same proportion where your n is your sample size. So remember that the condition that the same be large is not that n be at least 30, but that interval, no, your p hat now may there's a plus, there's a minus and plus sign here from your p hat, minus plus or minus your 3 square root of your p hat multiply by 1 minus your p hat all over your n. So this will serve as your lower limit and this will serve as your upper limit. So lie wholly within the inter of 0 and 1. So it should fall no within the inter of 0 and 1. So it should fall in between your 0 and 1. So for this slide, the standardized test statistic for a large sample hypothesis test concerning a single population proportion. So your C now will be equal to your P hat minus your PO. Then for your denominator, your square root of PO multiplied by 1 minus your PO all over N. Or we can simplify this one by simplifying your denominator since QO plus PO is equal to 1. So 1 minus PO is equal to QO. That's why in your second formula here, this is QO because 1 minus PO is equal to QO. So therefore, there are two formulas here. For example, if there is no value for QO and you don't want to compute for the value of your QO and there's a given value of PO, then you can use your formula number 1 here. That will be your formula number 1. If there's a given value of your QO, why not directly substitute this one to the given formula here for number 2. So the test statistic has the standard normal distribution. Yes, it is no, because even your sample is a large sample, no, still your distribution approaches no your normal distribution. So the distribution of the standardized test statistic and the corresponding rejection region for each of the following alternative hypotheses. So from our previous video lesson, I mentioned that uh, whatever your symbol no, in your alternative hypothesis, this will serve as your basis. No, if you're going to deal with to a one-tailed test or a two-tailed test, it can be left-tailed, right-tailed, or two-tailed test. So those tests will be dependent on the symbols that you're going to use no, in your alternative hypothesis. So it can be left-tailed, right-tailed, or two-tailed is shown in the figure below. So since here in your alternative hypothesis, there is a symbol here less than. As you can see that your P now is less than to your PO. So meaning to say this symbol less than represent that we're going to subject uh, an area in the left tail of your normal curve, because this will be a less than, no, meaning to say this belong to the negative part of your normal curve. So the rejection region here is in the left tail of the normal curve. Now, once your computed value will fall somewhere here in the shaded region, then you're going to reject your null hypothesis. What if your computed value will fall somewhere here? Then you're going to accept, no? You're going to accept your HO or your null hypothesis and reject your alternative hypothesis. Now, for the right-tailed, no, we simply use this figure. As you can see in your alternative hypothesis, so we use greater than symbol here, that your P is greater than to your PO. This greater than will represent this shaded region. And to say that the area that we're going to subject in this testing of a hypothesis is on the right side of your normal curve, or in the positive side of your normal curve. That's why if your computed value will fall somewhere here, then you're going to reject your null hypothesis. Same thing, no? If if your value will fall here, somewhere here, even that is a negative part of your normal curve, at some point here, if all your values will fall, no, under your non-shaded region, then you're going to accept your null and you're going to reject your alternative hypothesis. Why is that this alpha? So this alpha will represent this one, this boundary between your, or the separation of your rejection region and your non-rejection region. This alpha will represent a critical value. It can be from C or it can be from T table. So let's deal now with the two-tailed test. Let's first talk with what is the reason why we need to divide your level of significance by 2. Because in your two-tailed test, we consider, no, both your left and right side of your normal curve. So both sides. So from your alternative hypothesis, so there is a symbol here not equal to, meaning to say that there is a possibility, or we're not sure, no, if your P is less than or greater than your PO. So we just simply use this not equal to, because your alternative hypothesis will represent, though, or will never represent, I mean, an equality between your two variables involved. That's why we put this not equal sign between your P and your PO, no? Meaning to say, we need to subject both your left and right side of your normal curve. That's why we need to cut this level of significance into two equal values. That's why it's alpha over 2 in your left side and alpha over 2 in your right side. Now, with this figure, there are two rejection regions. So, meaning to say, whether your values will fall here, somewhere here, or somewhere here, still you're going to reject your null hypothesis. So the non-rejection region will start from this portion up to this portion. So there is a given interval from this one. So you're not going to subject the leftmost part or the rightmost part, no, as a part of your non-critical region, because there is no such thing. If you're dealing with two-tailed test, then there are only, no, or there is only a parameter that we're going to subject, no, in between your left tail and right right-tailed. So there is a given value of area that will represent the non-critical region, wherein if the computed value will fall in a non-critical region, then you're going to accept your null and reject your alternative hypothesis. So distribution of the standardized test statistic and the rejection region. So this will be the representation of your left tail, right tail, and the two-tailed test, as you can see, in our two previous slides. That will be your left tail and right tail test. And for this one, this will be your two-tailed test. We both your left and right sides of your normal curve are considered, and there is a portion from your leftmost and rightmost as a part of your rejection regions. So for this slide, we're going to deal with your table 1 that will represent your critical values for one and two-tailed tests as commonly used level of significance. So here there's a given values of your critical values for left-tailed tests, right-tailed tests, and two-tailed tests with respect to the given values of your level of significance. But at present, the most commonly used significant level or level of significance is 0.10 that we can map on the 90% confidence interval, 0.05 that we can map on the 95% confidence interval, and 0.01 that we can map on the 99% confidence interval. So these three values of level of significance are the most commonly used uh, value of alpha or level of significance at present. So in computing the value of the test statistic, note in this section assume that the sample is sufficiently large for the relevant test to be validly performed. So whereas to compute the value of the test statistic for each test using the given information and construct the rejection region for the test of alpha, which is equal to 0.05. So, and make the decision based on the answer of the C value. Here for letter A, so we need to test this one. Your HO now is equal to phi is equal to 0.5 versus your alternative hypothesis wherein your P is greater than your 0.5. Then your N is 360 and your P hat is 0.56. So this value of your sample is a large sample. It's a very large sample, that we're going to subject for this testing of hypothesis. But but let's deal with this one, as a part of the given. So using the formula, so we just simply use this formula. Then we just simply assume, that your P is equal to what? What will be your P? Your P hat is equal to your 0.56, and your P now, your P sub O, that will be your hypothesized uh, population proportion, that will be 0.5 based on the null and alternative hypothesis. So we just simply substitute the given values. Then as we simplify, that will be 0.06 all over your 0.0263. Then our final answer will be equal to 2.28. So our computed value for C is 0.28. So based on this, how can we move forward? So let's deal now with the next slide. So using this figure for our rejection region, since we use greater than in your alternative hypothesis as the symbol now between your P and your P sub O, then we need to consider your right side of your normal curve because it is greater than. Now, from the computation using your formulas, our C value or the computed value is 2.28, and the critical value for your alpha, no, from your right tail, which is 0.05, then your critical value based on your level of significance is 1.645. Now, the decision, so since the computed value is greater than the critical value, then we need to reject your null hypothesis because your computed value will fall somewhere here, no? So it will fall on the rejection region, meaning say you're going to reject your null and accept your alternative hypothesis because your computed value is greater than to your critical value. And what if your computed value is less than your critical value? Then you're going to accept your null hypothesis if that is the case. So for this letter B, so there is a given HO, which is your P is equal to 0.5 and your HA is P is not equal to 0.5. So there is a not equal sign here. So meaning to say that your uh, test statistic is a two-tailed test. So both your left and right side of your normal curve will be subjected. Then N is 360. So that's a very large population or sample, I mean. Then your p hat is equal to 0.56. So uh, we just simply compute for the value of your C. So your computed value is still 2.28, same value from your letter A example. Now, dealing with this figure, no, we just simply divide your critical value by 0.25. So there is a change now with the value of your critical value. That's why you need to be familiarized, no, with the value of your critical values for the left tail, right tail, and your two-tailed test because there's a difference between those values. So it can change, no? So based on here, no, once we divide your alpha or your level of significance by 2, that will be 0.025. And the value that we can map on these two-tailed tests and for us to have the critical values, no, so we just simply use the table uh, that we presented, no, a while ago. So that will be negative 1.96 and positive 1.96 here. So both sides, so there is a positive and negative value of 1.96 because both your left and right side of your normal curve will be considered. So since your computed value now is 2.28 is greater than your critical value, still that your computed value will fall somewhere here, no, right after your 2.0. So now, since the computed value is greater than the critical value, then we're going to reject your null because your computed value falls on the critical region or the rejection region. Then we need to reject your null and accept your alternative hypothesis. So mean to say that our conclusion, no, will be based on this statement that your P is equal to 0.5. We don't know if your fee is less than or greater than to your 0.5, but one thing is sure now is we need to reject your null hypothesis and we need to adopt your P, which is not equal to 0.5 and accept your alternative hypothesis. So for letter C, testing, no, we need to test your HO now. Your HO is equal or somehow P is equal to 0.37 versus your alternative hypothesis wherein your P is less than 0.37. So N is 1,200, so a very large sample, then your P hat is 0.35. So as you can see here in your alternative hypothesis, so we use the symbol less than, no? So we just simply substitute the given values to your given formula, then we can arrive on this value. So that will be negative 0.02 all over your 0.013937. So that will be equal to negative 1.435. So as we mentioned, no, from our previous video lesson, that if we're going to decide if that is a one-tailed, two-tailed, left-tailed, or right-tailed, no, it will be dependent on the symbol that we use on your alternative hypothesis. So since we use less than on your alternative hypothesis, means to say we're going to subject the left side of your normal curve. It is a one-tailed test, then we apply your alpha, which is equal to 0.5. Then if we use the table, no, or that we presented a while ago, then your critical value now is negative 1.645. So if we compare this negative 1.645 to negative 1.435, then the absolute value or the computed value negative 1.435 is less than to your absolute value, absolute critical value, which is negative 1.645. Then it will fall here, no? As you can see, somewhere here, your negative 1.435. It will fall before the critical region or the rejection region. That's why we really need to accept your HO, then reject your alternative hypothesis. So meaning to say in this case that there is no significant difference, no, between your V and 0.37. That's why we need to adapt this one, that your P is equal to 0.37. So let's deal now with solving problems involving the test of hypothesis on the population proportion. So for example, number 1, so a soft drink maker claims that the majority of adults prepare its leading beverage over that of its main competitors. To test this claim, 500 randomly selected people were given the two beverages its random order to taste. Among them, 270 preferred the soft drinks maker's brand, 211 preferred the competitor's brand, and 19 could not make up their minds. So meaning to say these 19 are undecided. Determine whether there is a sufficient evidence at 5% level of significance, meaning to say this will be the maximum error that a researcher wants to meet to support the soft drinks maker's claim against the default that the population is evenly split in its preference. So for our solutions, so we will use the critical value approach to perform the test. So we must check the sample is sufficiently large to validly perform the test. So since here there's a formula for population proportion, since 270 choose the soft drinks maker, no, over 500, so the population proportion that deals with their beverages is 0.54. So once we apply this formula here, that will be your p hat minus your p hat over n. So we apply. So here approximately equal to 0.02. So hence, so we can apply this formula. So your p hat now is 0.54 plus or minus here, as you can see, that will be your lower value and higher value. As you can see, there is a minus and plus sign here. 0.54 plus or minus your 3 multiplied by square 0.02, as you can see here, no, approximately equal to 0.02. So whatever our value here, that will be equal to 0.48 and 0.54 plus 0.06 intersection to your 0 and 1. So the sample is sufficiently large. So as you can see now, 500 is sufficiently large, no? Without solving in this one, as you can see that we consider that your sample is a large sample if your sample is 30 and above. So if that is a 500, if that is 500, it's automatic that is a large sample. So for step number 1, we're going to formulate the null and alternative hypothesis. Since we always said that your null hypothesis will show you an equality between your two variables involved, then your P now is equal to 0.05. And for your alternative hypothesis, your P now is less than 0.5 at the level of significance which equals 0.5. Now, as you can see here, greater than, so we simply use greater than. Meaning say we subject, no, we're going to subject the right tail of your normal curve for this testing of hypothesis. So where P denotes the proportion of the adults who prefer the company's beverage over that of its competitor's beverage. Now, it is a right-tail test because this is greater than. So for step number 2, identify the test statistics to use. So we just simply use this C value formula. And there's a given value of your PO, your P hat, no, based on the given values, we can compute for your P hat and your PO. Then we just simply substitute the computed values and the given values to the given formula and has the standard normal distribution. So for step number 3, using a simple random sample of observation, compute the value of the test statistics. So we're going to use now the given value for step number 2. So we apply or we substitute the given values and the computed values, no, for this formula. So upon simplifying, we can arrive on this simplified form that will be 0.04 over your 0.022360679. So our final answer is 1.789. So this value is a positive value, no, that we're going to compare now to your critical values based on the level of significance, and using the table, we can identify the critical values for your right tail test. So for step number 4, make a decision on whether to reject or fail to reject your null hypothesis. So since the symbol in HA is greater than, no, a while ago I said that if we're going to decide if that is a right or left tail test, it will be dependent on the sign that we use on your alternative hypothesis. That's why if that is greater than, then it's automatic that will be a right tail test. So there is a single critical value here, which is equal to C sub alpha or your C sub 0.05. Since we set that your level of significance is 0.05, from the table 1 of commonly used significance level, so the critical value here now is 1.645. So the computed value is 1.789, which is greater than the critical value. So the decision is to reject your null. So for example, if this is your normal curve, somewhere here will fall your critical value, which is 1.645. If this is your shaded region in this part, that will serve as your rejection region. Your 1.789 will fall somewhere here. That's why we need to reject your null hypothesis and accept your alternative hypothesis. So statement the conclusion. So the data provide sufficient evidence at 0.05 or 5% level of significance to conclude, no, that the majority of adults prefer the company's beverage to that of their competitors, because your P now will be equal to the given values. It's not, it's greater than, no, to the given values, because we really need to accept your alternative. So for example number 2, a manufacturing company claimed that a majority of 50% of the city consumers uses, no, their toothpaste X in a random sample of 200 consumers. 125 are users of their product. So based on the data, it is safe to say that the company's claim was valid. Is it safe to say that the company's claim was valid? So we just simply use your level of significance, which is alpha. So that will be equal to 0.05, no, or 5% level of significance. So for our solution, let's start with step number 1. It's about formulating the null alternative hypothesis. Your HA now here, HO I mean, your P is equal to 0.55, meaning to say that there is no significant difference between the claims of the company on the proportion of consumers using their product with that obtained from the sample. So as you can see, there's an equal sign here. So meaning say it represents no that there is no significant difference no between the claims of the company. So for your alternative hypothesis here, your P is not equal to 0.55 because in your problem there is no word or keywords being mentioned that is something the value is greater than or less than. No, we just simply assume since your alternative hypothesis show you or will never show you an equality. That's why we assume that your P is not equal to 0.55. As long that your statement does not show you an equality, then that will be your alternative hypothesis. But again, we're not sure. The problem was not specific like that, no? So we need to deal with the not equal sign because we're not sure if the value will fall before and after your parameter. So there is a significant difference between the claims of the company on the proportion of consumers using their product with that obtained from the sample. So level of significance is equal to 0.5. Then for step number 2, identify the test statistic to use. So we just simply use this formula and we just simply substitute the given values and computed values and the assumptions are for us to conclude then and has the standard normal distribution. So we just simply use the C value because we assume that there is no standard normal distribution for this one. So for step number 3, so we're going to compute the value of test statistics. So we just simply use this formula and we substitute the given values, the computed values for this one for the value of your P at PO and your N. No? As we arrive on the simplified value, that will be equal to 0.075 over your 0.035178118. So that will be equal to 2.132. It's a positive 2.132. And for step number 4, make a decision on whether to reject or fail to reject your HO. So our decision, we're going to reject your HO. So the statement, the conclusion. So if we're going to reject, so meaning to say that our conclusion that there is no significant difference, no, the claims. So there's an error here. So if we reject your HO, our decision is to reject your HO, no, then meaning to say that there is a significant difference, no. So there is a significant difference between the claims of the company on the proportion of the customer using their product with that obtained from the sample. So there's a typographical error here, no? So there's no word supposed to be in our statement because if we reject your HO, then there is a significant difference between the claims of the company. So for example number 3, suppose that the average passing percentage in the College of Nursing in the last 10 years in board exam is 97%. And this year there were 300 students who took the exam and passing percentage is 98% since 294 passed. So does this mean that the percent crop nursing graduates is superior compared to the previous batches? Use 0.05% of level of significance for us to compare these values. So given, so your p hat or your population proportion is 0.98, your x is 294, then your n is 300, your PO, your hypothesized population proportion, that will be equal to 0.97. So for step number 1, formulate the null and alternative hypothesis. So let's start with this null hypothesis. Your HO now is P is not is equal to 0.97 because your null will show you an equality between your two variables involved. So your alternative hypothesis now, your P is not equal to 0.97 because in your problem, there is no keyword or words being mentioned that will show you, that will give you a second thought that that we need to consider your left-tailed or your right-tailed. No, so there is no being mentioned there that is greater than or less than. So something meaning to say that we assume that your P is not equal to 0.97. So step number 2, identify the test statistic to use. So we just simply use again this formula, no, and we assume that has the standard normal distribution. So in your step number 3, compute the value of the test statistics. So with the given formula, we just simply substitute the given values and computed values for your p-hat, your p-sub o, and the given value for your n. So the resulting value for your C value is 1.015, and we're going to compare this 1.015 to 1.645 based on the critical values that we can get on, no, to a two-tailed test, no, with respect to your level of significance, which is equal to 0.05. So for step number 4, so make a decision on whether to reject or fail to reject your HO. So our decision is to accept your HO. Why? Because 1.015 is less than 1.645. We say that this value, no, will fall on the non-critical region. That's why we really need to accept your HO because your positive, no, your positive 1.645 here will serve as a separation, no, between your critical region and your non-critical region. Since 1.015 will fall before 1.645, then it will fall on the non-critical region, meaning say we really need to accept your HO. So the null hypothesis cannot be rejected because your null hypothesis is a true statement based on the result that we get from the testing, or based on the result that we get from the test statistic. So for the activity, write what you think about the use of C-test of proportions. List at least 3 situations when the test of proportion is applicable. You just simply list down 3 situations or scenarios where we can apply the C-test of proportion and when the test of proportion is applicable. So when and why we need to apply your C-test of proportions, no, and when it is applicable. So thanks for watching. If you want to like, comment, share, and subscribe, so please do so. I'm Marvin Enriquez, your subject teacher for probability and statistics.